Here's another example. So think about an endowment. You want to endow an annual MBA graduation party at your alma mater. You want the event to be a memorable one, so you budget $30,000 per year forever for the party. If the university earns 8% per year on this investment, and if the first party is in 1 year's time, how much would you need to donate to endow the party? So the key word here is 30,000 per year forever. Okay, that's telling us that this will be a perpetual fund. So we can apply the PV of perpetuity equation. PV equals C over R, C being the 30,000 per year, the amount per year divided by the rate. So it will be 375,000. Okay, so the other way to think about it, if you put down 375,000 earning 8% per year, that will provide 30,000 each year for the party. All right. So perpetuity is a case when payments will be constant over time. What if the cash flows will be growing? Okay, so we call that a growing perpetuity. This is a timeline, how a timeline looks like. Okay, so we also need a new parameter here, which is G. The G here captures the growth rate in cash flow. So in the first year, payment will be just C. The second year, okay, so notice that the payment is growing. So it will be C times 1 plus G, okay, just like when we were doing compounding. And for year 3, so from a previous year, that's another 1 plus G growth, okay, and ongoing. Now the PV of all of these, okay, remember how we deal with PV of multiple payments, right? So if we calculate that, it could be reduced down to this equation. This is much easier to work with. And anyways, this is an infinite series. So after you simplify the infinite series, it just reduced down to this very simple equation, which is C over R minus G. Okay, so we have the cash flow, rate of return, and growth rate in cash flow, all three variables in this equation. So from a previous one, we made a little change here. Okay, so we need to account for the effect of inflation on the cost of the party. Although 30,000 is adequate for next year's party, students estimate that party's cost will rise by 4% per year thereafter. Okay, so this is telling us that it's growing thereafter forever or for indefinite periods. To satisfy the request, how much do you need to donate now? Okay, so we want to evaluate the present value of this growing perpetuity. So using the equation in the previous slide, it's C over R minus G. So in the denominator, we have R minus 4% being the growth rate. Okay, so the amount as of today would be 750,000, so which is double from the if there's no growth rate. All right, so the last concept for this this is a relatively long slides. Okay. Last concept, which is also a very important concept in finance, is called term structure of interest rates. So term structure is about the relationship between the investment term and the interest rate. Okay, so for example, if you have a treasury bond which pays 4%, or quite high, for 30 years. Okay, so And you also have different the bonds at different maturities, then the interest rate is going to be different. And normally, we will expect that the longer the term, interest rates will be higher. That's a normal case, but there are also exceptions. So yield curve is basically a plot of its term structure. Okay, so for example, we will talk about bond yields and the yield curve for a bond. It's a function of bond's maturity date. So here's some example based on historical data back in 06, 07, and 08 November. See, we have term here, okay, from 0.5 to 20 years. And these are the rates in that month. Okay, these are the rates for U.S. Treasury security. Well, back then, interest rate was still very high. Then this is the yellow line, okay, and the red line. So we have three term structure here at three different dates. Now, if we plot that, these are three yield curves. Okay, so November 08, November 07, November 08. This is 06, sorry. Okay, so yield curve, you can see that has different shapes, right? November 08, that's the starting of the financial crisis. Okay, so we have upward sloping yield curve. This is relatively flat, and for this one, it's inverted little, then staying flat. Okay, so normally it's upward sloping curve, but there are also times when yield curve has different shapes, has a little partially inverted, which usually some quarters before a recession coming, and more commonly we'll see upward sloping yield curve, basically saying that long-term interest rates will be higher than short-term interest rates. Okay, so this is the concept of term structure and yield curve.